નમસ્કાર, હું આદર્શ છું. વેલકમ ટુ આદર્શ એજ્યુકેશન સોસાયટી.
Hello students, today we will study about the relationship between zeros and coefficients of a polynomial. This is the topic of standard 10, chapter number 2, polynomials, right? So, in previous classes we have studied about that there are three types of polynomials we can classify based on the degree of the polynomial. So, there are three types of polynomial. One is linear, second one is quadratic, and third one is cubic polynomial. So this topic is about the relationship between the zeros and the coefficients. So we will study this topic one by one. First topic is for the linear polynomial. So first we will study about the linear polynomial, that what is the relation of the zeros and coefficient for the linear polynomial. So the standard form of the linear polynomial is p of x is equals to ax plus b. Okay, so let's take an example. P of x is equals to 7x plus 5. So here, what is the coefficient of x? That is 7, and the constant term here is 5. So we will denote 7 as a. So a is equals to 7 and b is equals to 5. Now to find the zeros of the given polynomial, linear polynomial, what we have to do is we have to take p of x is equals to 0. And what is p of x? P of x is equals to 7x plus 5, and that is equals to 0. So by taking this 5 to the right hand side, we will get 7x is equals to minus 5, and that is why now by taking this 7 to the right hand side, we will get x is equals to minus 5 upon 7, and we call that as the zero of this linear polynomial. Why? Because by putting this value in this polynomial, the total value of this linear polynomial becomes 0. So now what is, see here, this is one of the zero of the linear polynomial, and we know that linear polynomial has at most one zero, right? So now what is this? Minus 5. And what is 7? See, minus 5 we can write down as minus remains as it is. Instead of 5 we can write down b, and instead of a we can write down 7. So what is the relation? Is 0 of this linear polynomial is equals to minus b upon a. What is b? Minus remains as it is. B is the constant term and a is the coefficient of x. So this is the relation for the linear polynomial between 0 and coefficients. 0 of linear polynomial is equals to minus constant term upon coefficient of x. Second type is quadratic polynomial. The standard form of quadratic polynomial is p of x is equals to ax square plus bx plus c. So one of the example of quadratic polynomial is p of x is equals to 3x square plus 5x minus 2. So now to find the zeros of the given polynomial, we have to take p of x is equals to 0. So what is p of x? P of x is these three terms, that is equals to 0. We have to take is equals to 0. So now to factorize this term, what we have to do? We have to use the splitting the middle term method. So 3 2s are 6. We have to factorize 6 such that the factors of subtraction of the factors gives us 5. So we have to factorize 6 as 6 ones are 6, such that 6 minus 1 becomes 5. So we can write down here is 3x square plus 6x minus x minus 2 is equals to 0. Now by taking the common from this two term, what we can take the common is 3x. So by taking 3x as common, what will remain here is x plus what will remain here is 2. By taking common from this two term, we can take minus 1 as a common. What will remain in the bracket is x plus 2. X plus 2. Right? So x plus 2 is again common in this first term and this second term. So x plus 2 is common. So what will remain is 3x minus 1 in the another bracket is equals to 0. Now by comparing this term with 0, what we will get? 3x minus 1 is equals to 0. So that x is equals to plus 1 upon 3. Again we will compare this x plus 2 with 0. We will get x is equals to minus 2. Now we will tell these two zeros, one zero as alpha and second one as beta. So one of the zero alpha is equals to 1 upon 3 and second zero beta is equals to minus 2. Now what are the coefficients of our polynomial? See, a is equals to 3, b is equals to 5 and c is equals to minus 2. Is there any relation between this coefficient and 0? No, currently there is no direct relationship between this 0 and this coefficient. So to define the relationship, what we have to do? We have to add both these zeros. So by adding both the zeros, what we will get? Alpha plus beta. Alpha plus beta we will get 1 upon 3 minus 2. And by simplifying this, what we will get? Minus 5 upon 3. Because 3 is the LCM. And we have to multiply this with 2 with 3. 3 2s are 6. 1 minus 6 upon 3, that is minus 5 upon 3. And what is the multiplication of both these zeros? Alpha and beta. Alpha into beta. So alpha is 1 upon 3 and beta is minus 2. So by multiplying these two, we will get minus 2 upon 3. Now there is a relation between the coefficient and this addition and multiplication of zeros. So what is the first relation is? Alpha plus beta is equals to minus 5 upon 3 is equals to, now what is 5? You can see that 5 is the b. We can put down it as b. What is 3? Instead of 3 we can write down a. So the relation alpha plus beta is equals to minus b upon a. This minus sign remains as it is. So what is b and what is a? Minus remains as it is. B is the coefficient of x. See here, b is the coefficient of x. And what is a? Coefficient of x square. So this is the first relation. Alpha plus beta is equals to minus b upon a. What is second relation? Alpha into beta. See, minus 2. What is minus 2? C. We can write down instead of minus 2 c, and instead of 3 we can write down as a. So the second relation alpha into beta is c upon a. Now what is c? C here is the constant term, and what is a? A is again the coefficient of x square. So this is the relation between the coefficient of 0 for the quadratic polynomial. Alpha plus beta we get minus b upon a, and alpha into beta we get c upon a. The third type is of cubic polynomial. The standard form of cubic polynomial is p of x is equals to ax cube plus bx square plus cx plus d. One of the example is p of x is equals to 2x cube minus 5x square minus 14x plus 8. So to find the zeros, we have to take p of x is equals to 0. Here we are not actually finding the zeros of this polynomial. So the zeros we have given in the example is, one of the 0 x is equals to minus 2, second one is x is equals to 4, and third one is x is equals to x is equals to 1 upon 2. So here we will tell the zeros as alpha, beta and gamma. First 0 alpha is equals to minus 2, second one is beta is equals to 4, and third one is gamma is equals to 1 upon 2. And what is the coefficients of this polynomial? A is equals to 2, b is equals to minus 5, c is equals to minus 14, and d is equals to 8. So here also there is no direct relation between these zeros and this coefficient. So to find out the relation, first of all we have to add all these three zeros, alpha plus beta plus gamma. So what the result we will get here is, alpha is minus 2, beta is 4, and gamma is 1 upon 2. So by taking 2 as an LCM, we have to multiply this with 2, we will get minus 4. Again multiply with 2, we will get 8. 1 remains as it is. So in the numerator we will get 8 plus 1 is 9 minus 4, that is 5, and denominator is 2. So the alpha plus beta plus gamma is equals to 5 upon 2. Now see, is there a coefficient with the value 5? Yes, but there is minus 5, not 5. So we can write down this 5 as minus of minus 5. We can put down two minus signs together because minus minus becomes plus. So we are not actually changing the value of this 5, but we will write it into another form, that is of minus minus 5. So now this minus 5, we can write down it as minus 5 is equals to B and 2 is equals to A. So here we will get the relation minus 5 is equals to minus sign remains as it is. This minus 5 is B and this 2 is A. So the relation we will get here is alpha plus beta plus gamma is equals to minus B upon A. What is B? B is the coefficient of x square, and what is A? Coefficient of x cube. This is the first relation. Second relation is alpha into beta into gamma. That means the production of all these three zeros. So minus 2 multiplied by 4 multiplied by 1 upon 2. Now this 2 and 2 will cancel out each other. Minus 4 will remain as it is. So is there any minus 4 in the given coefficient? No. So we can write down minus 4 as minus 8 upon 2, because by cancelling the common factor we get the minus 4 again. So why we do this? To get the relation between this 0 and the coefficient. That is why we write down it into another form. So now what is minus 8? Again the minus sign remains as it is. We can write down 8 as D and 2 as A. So this relation we will get minus D upon A. What is D and what is A? D is the constant term and A is the coefficient of x cube. This is the second relation. Third relation is alpha into beta plus beta into gamma plus gamma into alpha. So here we will get minus 2 into 4 plus 4 into 1 upon 2 plus 1 by 2 into minus 2. What we will get here is minus 8. These 2 and 2 will cancel out each other and minus 1 will remain. So minus 8 minus 1 total is minus 9, and here 2 to the 4 we can cut down. So plus 2 will remain. Minus 9 plus 2, that is equals to minus 7. Again there is no 7 here, but we can write down minus 7 as minus 14 upon 2. Now what is minus 14? Minus 14 is C and A is 2 is A. So what is C? C is the coefficient of x and A is the coefficient of x cube. This is the third relation. So the three relations we get for the cubic polynomials are alpha plus beta plus gamma is equals to minus B upon A, alpha into beta into gamma is equals to minus D upon A, and alpha into beta plus beta into gamma plus gamma into alpha is equals to C upon A. All this in three relations, the denominator remains the same. That is the coefficient of x cube, right? So this is all about this relation between the 0 and the coefficient of polynomial, right? Thank you.
Thank you for joining us.